Hello everybody, we're going to be working on our Python review exercises from Unit 8 today, and I have the exercise document up on the screen here. I'm also logged into my code share page, and of course if you're watching the video it's going to be pretty relevant because this content will probably be gone from there by the time I get there. But what I did as an initial challenge here for the students is I asked somebody to volunteer their solution for the first exercise. And really what this first set of exercises is all about is just going through and repeating all of your basic skills and learning, or relearning what you learned last semester or whenever you learned it. So this first one just really wants us to put stuff on the screen, and it doesn't really take a lot to put that. You basically use the print method to do that, but it did have you look up sales tax rates for a few states. So I'm hoping that you guys did that, and from what I see in the background here, Jack volunteered this solution. And I'm going to take this solution from my code share window, highlight it, and copy it. And this is kind of a neat environment, the code share environment. It's one of many tools like this, where it allows you to collaboratively work on code with someone. Now, the one thing that I'm noticing here, Jack, is that you are running a main method. Okay, so that's not something we normally teach in the first chapter, although some people when they teach Python will tell you this is how you should always do it. Yeah. Right? And functionally, as a matter of practice, if you're writing a real application, that might be a good practice. For a real simple thing, the reality is that we could probably eliminate the methods and just run it, but really what's happening here is we're defining a method where all the work is happening, and then we're just calling that from the main method and then getting it to execute. You will notice here that you have an extraneous parenthesis, and I don't know if that was from you pasting it in or if it was just in the code window in code share. I'm assuming that's probably the case because otherwise you probably wouldn't have turned it in that way. But it's an easy fix, right? Just get rid of that. And the Spider, the tool that we're using right now, it's full-blown IDE that does kind of like on-the-fly debugging. So if you're seeing little flags in the margin, sometimes you know to look at them before you go running your code because chances are it'll probably fail. Let's go ahead and run this and see what the output looks like. All right, so that looks pretty good. Now, one of the things that they're going to push you towards, and I'm not a real stickler on this because that's not really the point of the assignment, is they wanted you to kind of make it look all pretty, right? So they were making kind of like a little table here with underscores and stuff, and it looks like the tax rates are kind of lining up. But then it gets kind of subjective, really, because you have a bunch of information from different sources. So you could go through and use some of the print functions to clean it up, or just extra spaces or whatever. But I think that this is functionally good. So are these the actual tax rates? Yeah. So Montana's got a 6.9, and okay, I knew Rhode Island was high. I didn't realize Montana even had a sales tax. Yeah, I thought there was going to be nothing because they want people to come there. But that's apparently not the case. Wisconsin actually has a pretty low tax rate when it comes right down to it. And this is kind of interesting to me because the Illinois tax rate is under 5%. It's all the county taxes that crank it up. So if you shop in Chicago, it can clear 10% in some situations. A lot of people also don't know that when dealing with sales taxes that they usually have a different tax rate for regular retail sales and for restaurants, hotels, and events. Yeah, so like in the city of Milwaukee, I know that restaurants, hotels, and all that type of entertainment stuff, I think is like 8 or 8.5%. So whenever you go out to dinner for somebody, you should always research that, because it's like, well, here's my extra 10% for a tip. It's like, well, hey, first of all, that's cheap. It should be 20% for a tip, right? And then secondly, you should also add sales tax, and a lot of people don't do that, and you wonder why you end up short. But in some places, they also charge sales tax on silly things like food. Wisconsin does not. So you cross the border into Illinois, the sales tax is on food too. So why is Woodman strategically placed just over the border? So it's super cheap, and they save all that sales tax. So it's a huge, huge saving for a lot of people. So Jack, I think this turned out pretty good, and I see that you used a couple little print tricks here. You did the multiply right? I love that trick where that Python allows you to do that. So instead of like putting in 50 equal sign, you just multiply it by 50 and there they are, and that looks good. So I think you did a great job on this one. All right, for this next one, it says, this is one of the business exercises, by the way, which is towards the back end of the chapter. It says, the following pseudocode describes how a bookstore computes the price of an order from the total price and the number of books that were ordered. And they, list you the steps here. It says, translate this pseudocode into a Python program. So let's go ahead and start to do that. First of all, I think what's kind of helpful here is to keep in mind, as you're doing these review exercises, what the chapters are about. So, so that you don't get into the situation where you think you should do techniques that are more advanced than the ones that are already listed in the chapter. Not that you couldn't, and that would actually be fine. But the steps here are pretty simplistic. It says, read the total book price and the number of books. So where are we reading that from? What's the assumption? That we're getting it from the user, right? Okay, so that's a user input statement. It says compute the tax, 7.5% of the total book price. So if it's 7.5%, tax sounds like one of those things that you might want to consider setting as a constant, even though Python doesn't technically allow for that, right? Remember that little thing that we talked about last time. It says compute the shipping charge, $2 per book. That also sounds like it might be a constant. The price of the order is the sum of the total book price, the tax, and the shipping charge. Print the price of the order. Okay, these are pretty simplistic steps. Why don't we start with, let's start by actually creating a file. But before I create a file, what I always like to tell people is, it's really smart if you start with a little bit of file management. It goes a long way before you start to code. And this is a hard thing for people that are new to coding to learn, I think, and how you proceed with this is really kind of functionally up to you. If I was teaching my regular Python class, you would have a whole smattering of exercises from chapter 2, and I would want you to create basically a chapter 2 folder somewhere, and then put all your work into that folder. Then you can zip that whole folder or whatever, and all your stuff's in the same place. Because this group of assignments really kind of spans chapters, what you might want to do is just break it down into Python Review 1 and Python Review 2. So that's kind of what I'm going to do here. So I have a course folder in my hard drive here, and I'm actually going to create a new folder within it and just call it Python Exercises. And then inside that folder, I'm going to create another folder called Review Part 1. Name it however you choose to name it. But that's where I'm going to store my work, and I think it's good to start with file management always. Another real quick and handy tip, folks, and a lot of people overlook this, is when you're working with any file system, our modern consumer operating systems, both on Mac OS and the PC, Windows environment, will kind of dumb down the file folder windows with intent. One thing that they do is they usually lock you out of seeing your file extensions. And lock is not really a good term, but they usually block your file extensions from being visible, thinking that who needs to see those, right? But I'm going to tell you, as IT professionals, you should always have them on. So what a lot of people don't know about Windows 10 is when you are in these file folder windows, that there are all these ribbon menus that pop up. And if you notice, like when I opened my window at first, mine was just turned on. And if you saw how I just hit the little arrows there and the little pin, my strong recommendation to you is that you always leave them open so you can see all the tools that are available. Underneath the view menu, there is an option, and right now it seems like my machine's hiccuping again like it was before, where it says file name extensions, and there's just a checkbox for it. My strong recommendation is you have that box checked so that you don't go misnaming your files with extra file extensions, which a lot of students tend to do, or be deceived into thinking that a file is something that, that it's not. All right, so now that I have my folder set up, I'm going to go ahead and go back to my IDE, and I'm going to choose to create a new file. All right. First thing you do when you create a new file is what? Save it, right? Save it, name it. Yeah, that should always be your first step, and a lot of people do not do that. My really strong encouragement is that you always do that as a matter of practice, because it will save you from having a lot of problems in the future, trust me. This particular exercise is exercise 2.32, so you could call it 2.32 if you want. And I think the point of the exercise is, maybe you could call it bookstore or something like that. So maybe I'm just going to call it 2.32, and because I'm not always comfortable putting dots in file names, I'm going to switch it to a dash, and I'm just going to say bookstore, like this. And really, it's probably a better habit to not even have spaces in it, so this is what I'm doing. Now when I save this, this will save with a .py extension, so if I refresh, and of course I didn't save it to this location, did I? All right, so let's go ahead and fix that. Let's do a save as, and make sure that we put it right in the right spot here. So I tend to use my Google Drive for these things. You can, of course, use whatever folder location you want, but I want to make sure it's in the right spot. So now it's in the right spot. And let's, not to be paranoid, but let's go check. Okay, there it is. Now I feel comfortable, okay? But file management is critical. If you're not really good with managing files, as anybody that works in this field, you should work on that aspect really hard in my mind. All right, going back to the problem description here, we have this. It says, read the total book price and the number of books. So it sounds to me like we're going to need some input statements. And then we also have two pieces of information that to me look like they're hard-coded constants. So I'm actually going to start there. So this is what I'm going to do first. And whatever your pattern is really kind of up to you. You'll notice that Spider automatically does some commenting at the top of each file. Like for one thing, it grabs the username off your system and drops you in as an author. Not a bad thing. It timestamps it. Also not a bad thing. I also want you to notice the type of commenting that they're using. First of all, they have kind of a mix here between the # approach, right? And then the double quote approach, which is kind of like the CSS style where you can put a whole bunch of stuff inside there. This code will not execute. What I'm going to do first is I'm going to paste in a comment that tells me what the heck I'm doing. So it's not a bad idea. What I would always encourage my students to do in class when I was teaching the fundamentals of Python is, why don't you just take the whole exercise description and drop it into your program as a comment, and then you don't have to go flipping screens, especially if you're not a two-screen person, to see what you have to do. Now I could, I suppose, if I was really that sort of particular, I could take all of this, really, and I could maybe even drop it up here, and I have all the steps right in front of me. You can leave them there, you can delete them later, whatever. It's really kind of smart. So, yeah, take it for what it's worth. For right now, I'm going to leave them there. Not going to hurt a darn thing. All right. So the first thing, I identified that I think I see two constants that I'm going to put on the screen. So I'm going to begin by just defining those constants. All right. So I have one set up for tax rate and one set up for shipping per book. Remember, Python truly does not support constants. We're doing it by matter of convention of how we're naming it. So the fact that I'm naming things with all uppercase and putting underscores between logical words is a convention that's used in almost every programming language to indicate a constant. And here it's more of like an assumed constant than an actual one. But our goal would be not to change those. We could actually change them. I do want you to notice that the tax rate is listed in the form of a percentage. So it's 0.075 or 7.5%, because that's numerically what it is. And the shipping per book is at $2. Why did they put a 0.0 after it? Right. It also helps to determine how your calculations operate and what kind of output you get. Because it's a monetary amount, I think it's wise to always do that and treat it as a float. Next thing that we have to do is we're asked to get input from the user. So I'm just going to say get input from user. And what are we supposed to get? The total book price and the number of books. All right. So to me, whenever I think about those things and I'm getting input from the user, one thing you always have to remember with this is whenever you're grabbing anything from the user or a file or whatever external resource, you always have to have a place to put it. So where I'm going to start is by creating a variable to hold this. So let's do that. I'm going to create one called book price. And this is what I did last time. Why I put an underscore in it, I guess that's just what I opted to do. And the general statement for getting an input is this. So you just say input, and then inside of parentheses, whatever message you want on the screen. So I'm just going to say enter the total book price. Maybe leave an extra space there. However, when I grab the input, it must be converted to a number. Anything I grab from the keyboard is always text, so I can't do math with that. So knowing that, and knowing that I'm working with money, then what I'm going to do is I'm going to use the float command, or method technically, to take whatever that input is and turn it into a floating point integer. Floating point number, not an integer. All right. So that would be for the book price. We also need to get the number of books, and last time I named it this. Okay. This one's going to be converted into an integer, so I'll do that, and then I'll do my input, which also has a set of parentheses, and then you notice what I do, how I open and close my parens right away? It's a habit you guys should try to get into. If your IDE doesn't do it for you, you should do it for yourself. Some IDEs do, some IDEs don't. Here I'm going to say enter the number of books. Okay? And this will put the prompts on the screen, grab the input from the user, and then store it in the variables that we've created. All right, next step. All right, so I look at these, and we've already set these up, right? Well, we've set that up, and then we grab these values, but we didn't compute the tax and the shipping. But it says the price of the order is the sum of the total book price, the tax, and the shipping charge. So they're telling us what math to do. All right, so the next segment of our program is do the computations, or whatever you want to call it. Figure out, do the math, if you want to call it that. All right, so we're told that the sum of the total book price, the tax, and the shipping charge. However, some of those things need to be calculated, right? We got to calculate the tax. So we don't know what that is yet. So I'm going to set up a variable to hold the tax, and then I'm going to put in the fact that whatever our book price is going to be multiplied by the tax rate. That's how we're going to get that. Now that's giving us just the tax. All right. Now I will tell you there are ways to actually take all the math that we're going to do and put them into one statement. But if you struggle with the conceptual aspect of that, I always tell people you're better off breaking all the math steps into separate statements rather than combining a statement and having it be wrong. It's easier to go the other way. So for me, it's always better to do this. Now, if I wanted to figure out the cost of something with the tax, is this the math I use? Isn't that? So, no. This just tells me what the tax is. Do you know what the magic formula is for computing it with the tax? You put a 1 point, you put the 1 in front and then it computes it with. In this case, we actually are figuring out the tax separately, so I'm just keeping that in mind. The next thing we need to figure out is the shipping, and the shipping is also a formula, which is basically the number of books, right? That's the variable that we created, multiplied by, what did we call, the shipping per book is what we called it. So that's our constant. The other thing that I'll have you notice as we do this, and maybe I mention this next week, or last week, is when we're doing stuff like this and you're creating a bunch of variables, be verbose with what you name things and name them exactly what they are. Don't leave room for speculation, both for your sake and anybody that follows in your footsteps. I have some great stories of people and students that I've worked with over the years that would insist on like naming stuff whatever, and then it comes back to bite them in the long run. But what we're going to do now is we're going to look at how to do this. So we were already told, it says the price of the order is sum of the total book price, so I can just take the book price and drop it in, right? Then we're going to add to it the tax and the shipping charge, and we call the shipping just shipping. So the book price plus tax plus shipping, that's all our math. Does that look good to you guys? Is it possible that we could combine this into one statement? Absolutely. And how would you do that? Shipping, you see how it's highlighted right now? In parentheses, we would just add this formula. If we want to put in tax, we would just add that formula inside parentheses again, and functionally it's the same thing. You know, it takes a little bit of experience as a programmer to get to formulas that are really efficient. The argument that I'll get from students that are, you know, like thinking about building like real world applications is, does it take more processing to do the math in separate steps? The answer is yes, it does. Because I'm also storing it. So it takes memory location as well. If you can do the formula in one step and then store it in one location, it's significantly more efficient and will process faster than what I have here. But in terms of the logic and seeing it, to me it's more important to see the logic and have it right than to have it process fast. Then you can go back in the aftermath and optimize it any way you think is appropriate. Finally, we need to put the results on the screen, and I'm just going to say display the results. And do you need these comments functionally? Probably not, but you know, they don't hurt, right? And you know, when the program runs, it affects nothing. So it just makes the original file size a little bit bigger. So what are we going to put here to display this? Obviously, there's going to be a print command. I might suggest something that's meaningful. You could say total cost of the order is, and now you could just do this. You could just put in the price, right? But what I might suggest is that you practice some of those formatting commands a little bit. So I'm going to put in a $sign because we'd like to see a $sign. And then I forget which chapter it is, but somewhere, it must be chapter 2, they talk about all the print formatting commands that, frankly, are not unique to this language. The syntax that you see here, the $sign, .2f, you also use the same thing in Java. You also use the same thing in C++ and C#, and several other languages. And do you know why that is? Because they're all written around the C libraries. Somebody who wrote the C programming language decades ago created this stuff, and we just import the libraries and use them in our new things. There's a movement out there. I was having an interesting talk with a friend of mine who has been in IT for about like 50 years plus, saying that there are people out there that are rewriting all those imported libraries so that they're native to Python, so Python operates faster.
Oh, that'd be cool.
Yeah, I think that is really cool. But it's kind of interesting to know. Now, to append to this, I am going to put in, of course, we have to have the total price display, so I'm going to do this little statement here. This is the completed program, so let's go ahead and give this a run. All right, and it says enter total book price, so I'm going to click into my console window here. So what's my total book price? How about, okay, 100. Yeah, you know what, that's pretty smart because that's probably an easy number to work with. And it's easier to validate. All right, how many books are we buying? It's IT, one.
Yeah,
One used one. Well, let's put in 2. All right. So the total cost of the order is $111.50. I'm going to make 2 comments on this. First of all, is this right? Well, you know what? What you need to do as a programmer is you need to know what the right answer is for any program you write.
Right.
You always have to test it. So I know that 100 times 0.075 is 750. So then I can add 100 back to it, right? And then $2 shipping per book, so plus 2 equals 111.50, we're good. Because I'm just validating that it's right. Here's another thing that you can do, and this is just a suggestion from writing many applications over the years. Sometimes it's not enough to write the total price of something. So I always tell people, it's like if you went to a store and this printed out on your receipt, would you be happy with that? Is that what you would want your receipt to be? Yeah, I want some details on that receipt. So I would say, enter the number of books, cost of shipping per book. I would show all the math, I would show all the results, I would get really verbose. So this functionally completes the assignment. But is it best practice? I'm going to say absolutely not. Absolutely not. And I want you to think about that next time you guys walk into a store and they have a point of sale system and you're buying something and they scan it and it's on the screen and it prints to the receipt. Take a look at your receipt. Somebody programmed that. Take a look at the screens that are popping up. Somebody programmed that. It's not hard to program either. Cash register programs are a classic thing. We're going to move on to the next exercise now, so I'm going to pull that up on screen. So we're going to work on exercise number 3.15. So this one says, write a program that reads 3 floating point numbers and prints the largest of the 3 inputs without using the max function. So they want you to do an algorithm, right? And if you remember what chapter 3 is about, it's basically working with decision statements. So like if, else, etc. All right, so let's get started on that one. So what I'm going to do here is I'm going to create another new file. So I'm just going to click the new icon there. Right away I'm going to do a save as. This time it should go in the right folder. And here we are. And this is exercise 3.15. And what was the purpose of this one again? Largest number. So I'm just going to call it largest number, like that. All right, like I did with the previous example, just to make it a little easier on myself here, I'm trying to get the Word document up on the screen. There we go. I'm going to take the basic instructions for the assignment, and I'm just going to paste them right inside the top comment section. Just put it right there just for my own sake. All right. Now, if I'm not mistaken, and see, by habit I'm going back to the document when it's sitting right in front of me, it says write a program that reads in 3 floating point numbers. So right there that tells me we're going to have inputs, right? We're going to have 3 of them. Okay, well let's create that. That's going to be the first piece of work. So that's going to be created by doing this. I'm just pasting it in from my already solved version. And if you want, you could always pop in a comment saying get 3 floating point numbers from the user. Right. So I've set up 3 variables, num1, num2, num3. All of them are going to convert the input to a float. If you want to make sure that your user understands that they're putting in more than one, you could always do something like this. You can number them or enter first number, second number, third number. Because functionally, I will tell you that some people would look at, oh, I just did that. Especially if your input prompt is the same. So I always tell people, think about what the user is going through. Don't assume that it's awesome. Just because it works doesn't mean it's good. Not a good user interface. But this will work. All right. I mean, you could do enter another number. Or maybe, how about like this, enter yet another. Right, and you can get funny with it if you want. All right, so that'll accomplish that step. Now the next thing we have to do is we actually, figure out which number is largest without using the max function, which would do it automatically for us, right? So that makes you think in the back of your head, what does the max function do? Exactly what we're about to code. So, and that's why people create pre-built functions. Now, clearly, we're going to start with an if statement here. That's what the chapter's about. So I'm just going to start really basic. We have to compare multiple sets of numbers. You can do this in combination, or you can do it independently. So here's how I'm going to begin, and then see if you follow my logic. I'm going to start by checking a certain scenario first, and this is the one I'm going to check. I'm going to say, if the first number is greater than or equal to the second number, and that first number is greater than or equal to the third number, then it's the biggest number, right? Okay. So then my follow-up to that is just going to be, I'm going to set up a variable called, largest, and it'll be equal to number 1. Because that's what we just figured out, right? Pretty darn simple. What I'm not comfortable with Python is this else if. Every other language, they spell it out. So elif, okay, elif. Let's try the second scenario. Well, we'll just do the same thing with the second number. In fact, can I just copy the statement and tweak it? Sure, why not? So let's just copy all that. And we're just going to change it. So now we're going to be checking the second number first against the first number, and then against the third number. So if the second number is bigger than the other two, same thing. The largest will be num2, so we'll just adjust that to num2. This is one of those classic programming problems that's really kind of interesting, because there's really more than one way to solve it. Because you don't have to use combination if statements. You could do singular ones, but then you'd put other if statements inside of it. So why do you do the compound statements? Now, there's a couple little issues here, and the one is, what's an and what's an or, right? So whenever I have an if statement of any sort, I'm checking for the condition to be true. So if num1 is greater than or equal to num2, and the second condition is also true, then we go ahead and do it. If the statement was an or, only one has to be true. Okay, I just want to make sure that that little fact is not neglected. And then we don't need to check anything beyond that, right? Because if the first two numbers aren't the largest ones, the third one must be, right? You don't have to check anything. Yeah. So could I also put in another else if and then check that scenario? Sure. There's no reason to. From a processing standpoint in terms of speed and efficiency, this is faster. You don't have to check it, so why check it? You've already eliminated the possibility. Finally, you're just going to output the results. So however you want to say that, I'm just going to say output results, and then I'm just going to do a simple print, and I'm going to say the largest number is whatever I populated into the largest variable, and that's all there is to it. So this is a really simple exercise. It's more about remembering how to do an if statement than anything else. So hopefully this was a nice basic little refresher for you. Let's go ahead and do a Control-S to save. Let's hit the run button so it comes up in the console here. And so I'm going to put in a few numbers. Does take floats, right? And look, it gave me the right answer. Yay! All right, not a very complicated one, but still I would say a pretty important little exercise. You know, the big takeaway here is remembering how to do ifs and else ifs. You know, there's other ways to do decision statements. What are those? Like if I don't want to use else ifs, what can I use instead? Say that again. Yeah, there's other ways to do decision statements. I mean, typically if we have a simple statement, we will just say if, else, or if, else if, else, or if with no else. You know, those are the common ones. But what other mechanism do we have for doing decision statements? Well, while, you know, that's a good point, Cindy. While loops won't execute unless you have a condition to be true. Okay. So in a sense, that is a decision statement. But there's one other structure I'm trying to point you guys to that I didn't give you an exercise on that I think is pretty important. Remember the case structure?
Python doesn't use the case statement or a switch statement.
Not in the same way. It does have a variant of it.
Well, it does.
It does. So,
I like that.
yeah, I like it too. All right, let's move on to the next exercise. So the next one, oh, this is a fun one. I love this one, right? Because we get to explain math history with it. It's called the Fibonacci numbers. And this is a classic formula that's a really simple little thing. So whenever I have students and they see this sort of syntax, the syntax that you see on the screen is calculus syntax. I don't know if you guys have ever had any calculus classes.
No.
All right. The first thing I'll say is don't freak out to it. It's just a symbolic language, just like a programming language, that tries in a formulaic way, tries to explain the algorithm of what they do to do the math. And so the correlation between programming and calculus is really tight, because they have these expressions, just for example, like if I pull up a browser here, provided it works, right? We've had that issue today already. But let's just go to Wikipedia, of course, best source for everything. I can tell you it's not, right? So you see all these like formulas on the board, right? And they look all complicated. But the whole point of the notation, I'm hoping they have like some formulas in here that we can look at. But let's just look at the most basic of like little formulas, like something like this. And it says the function of x equals, that's how it reads, x squared. Now, the way you interpret that is this. The x on the left, this one, is the variable. The part on the right is the process that you're putting it through. So what you're really saying is, for a value that I pump in here, I'm going to do this to it, and that's what this value is. What confuses people mostly is that this is the same as this. It's the same x. But really, they're functionally different components. It's just like what's feeding it in. So this is a way for you to like kind of look at something that's very simplistic, and it has this correlation to programming, because what ends up on the left is the value that we're grabbing from what happens on the right. Sound familiar? It's like how variables work. So the fascinating thing is it gets more complicated, right? Like we would not write a math formula like this inside of a programming language. We would have to break it down into statements that fit on one line. We can't put stuff above each other, but you could do all that, and then it gets more and more complicated, and it looks more and more complicated. But like for example, whenever you see a statement like this, when it say the limit of h as we approach 0, meaning you're starting at some big number and you're counting down to 0. So you're getting all the values of it. And why is that pertinent? Because then it can plot on the graph. So it's kind of interesting field of study. It's not anything to be intimidated by. All of this stuff has special meanings where you can pump in values. And really it's all about explaining really what nature is doing mathematically. And you can look at a shape like this nautilus, right, which is based upon a logarithmic function. So nature does this automatically. And it creates these shapes as it grows, because that's just what the DNA does. It just happens to be a logarithm, and it's beautiful, right? Just a simple repeating pattern, and nature just does it. And the difficulty that we have is writing the formula that explains what it's doing, and that looks really messy because of the way that we think. So we're taking our thought process, trying to explain that. So that's really what a lot of it does. So it's a very fascinating field of study. But if you do the same thing now, and if you look up in fact, let's just stay in Wikipedia here, and let's just look up, and I want to find the Fibonacci sequence is what we call it, and I'm sure it'll pull up the same thing, right? And it's going to explain the same formula. So now I want you to go back to this document and then take a look at the little F's right? And then the main formula is this one. So that's the same one that they have up on the screen here. So they're saying the function of n is equal to the function of n minus 1 plus the function of n minus 2. Okay, makes no sense, right? But when we are dealing with numbers, what they're saying is, starting with 0, put in every number. And the value of this function will be the result of the first number minus 1 plus the second number minus 2. That's what it's saying. All right. So now they are doing this prerequisite here too, and I think that I wonder if this is a mistake, because I think this is correct and that's not. Okay, well, that's a function of 1 and the function of 2. So the function of 0 is 0. That's the predetermined value. But the function of 1 is 1 and the function of 2 is 1, because you can't subtract 1 from 1 and then from the second number and end up, so those values are preset. That's basically what that means. And this is what nature does too. So the first two results are 1. The second result, we're on the number 3. Okay, so we're subtracting 1 from 3, so we have 2. Then we're subtracting 2 from 2, so we have 2, right? So that's the third value. And as you keep building that formula up, it goes 1, 1, 2, 3, 5, 8, 13, and it keeps forming this pattern, which just happens to be the same shape as the nautilus. Now this is in squares, but this pattern can extend on into infinity. Isn't that cool? And if you look at it, these little squares, they just keep spiraling out. And this sequence is kind of, they consider it kind of a magical sequence because it describes what nature is doing automatically. And we have to think about how we describe it. But it's really a basic formula. You just take numbers on a number line, subtract 1 from the first one, 2 from the one that follows, add that together, what's your value? This is what you're doing. And that extends out, on into infinity. So when you take that shape and then you plot the numeric value along a curve, there's the curve that forms, and it keeps going on. They call it the golden spiral because it's built up on the golden ratio, which is that difference that we're talking about. So fascinating field of study. And if you happen to be a musician too, one thing that's really, really cool, if you guys know the band Tool, you ever hear of them? They have one of their songs where they play the parts according to the number of repeats here. So they play the part once, they play it twice, they play it 3 times, they play it 5 times, they play it 8 times. And I think they go up to 13 and then they cycle it again. And I think it's just brilliant. And when you listen to it, you have no clue that you're doing that, but they're doing something very mathematically complex and it's totally conscious. So I find that to be a lot of fun. All right, so applying music to math. But now what does that mean to us in terms of how the heck do we program this thing? Well, they're giving us this little hint here. So the hint is that we want to somehow, convert this into a program that actually makes sense. So this is, what was the exercise number on that? 415. So I'm going to pull up my code here on my screen. So I got this somewhere. Now people who love math always get a kick out of this one because it takes a little bit of thinking to make it happen. So the first thing let's do is make a new file. Second thing we do is do a save as. And we're going to call this 4-15. Why do they call it Fibonacci? Because that's the guy who figured it out. And all he was doing is describing what nature is doing. The first thing that we have to do, and if I'm not mistaken, is they're going to ask us implement a program that prompts the user for an integer n and prints the nth Fibonacci number using the above algorithm. So if I put in 8, it's going to calculate it up to the number 8 in the sequence and then give us the output. So we do need an input statement from the user, and I'm just going to begin by I'm going to call my variable n. That's the only input that we're going to need. We're going to convert it to an integer because it told us to. And then our input statement's going to say something to the effect of enter an integer. Nice, short, and sweet. And that's not where I wanted that space. Wanted it there. Now we have to convert that formula into something meaningful. Now we have this problem. If they type 1 or if they type 2, well, that's a special issue. That's a really good question. We have to accommodate for it. We do. All right, so, but with these two scenarios, if they put in a 1 or a 2, we have to have a scenario, and listen to just the way I said it. If they put in a 1 or a 2, if, right? Okay, so that's kind of the first clue. The way that I did it last time is this. I just set up an if, and I said if n equals 1, and I set up a variable to receive the result, the output's going to be 1. If n equals 2, it's going to be 1. Why? Because that's what the formula tells me to do. Those are the scenarios for that. From there, if one of those two scenarios does not happen, then we have to do this. Else, and now we got to put in that formula. All right. Now, there's a little bit of a complication here in that they're kind of giving us a little bit of a hint. And I'm going to tell you right now, it's more than just a hint, right? Because what they're trying to do is teach you how to fold the paper according to this. Okay, so, yeah. So what I'm going to do is this. I'm going to actually copy those variables in. So I'm going to say fold 1, and I don't want it at the margin, I want it indented. It's taking me one space past. Sometimes it doesn't like that, so let's fix that. And we're just going to say that's going to be at 1. Fold 2 is going to also be at 1. That's already established. What happens in the aftermath of this, we're going into a loop. And this happens very often with a lot of these formulas because they kind of loop back on each other, and the whole Fibonacci thing is all about a loop, the spiral, the golden spiral. So we're going to write this equation. We're going to say for I in range 2, comma n. N being whatever number the user put in. So it's going to run from the number 2 up to whatever. So if they type 54, it's going to run up until that number. Why do we start at 2? Because 1 is already, 0 and 1 are already taken care of functionally. So we're starting at 2, and we're going to continue on from there, basically. All right. Next thing I'm going to do is I'm going to take that place where I'm holding whatever the result is, and I called it F nu, Fibonacci nu, I guess. We're going to first add fold 1 plus fold 2. Now, keep in mind here that the author is trying to do you a favor by giving you the formula, right? You guys didn't have to go out and hunt it down and figure out how it works. And it's not really a math class per se, but there is math and programming. And once you understand how to convert some of these really complicated, like calculus and trig functions into programming languages, it can kind of do some pretty cool things, especially when you start doing graphics. Because a lot of the stuff that we see in nature is just kind of like that. The other thing that we're doing is we're going to take fold 1 and set it equal to fold 2. Why? Because they're basically the same, right? And then fold 2 is going to become the new result. So here's what's happening. These numbers are going to increment each time. So they're going to hold the previous two values every time we go through the loop, and then keep pushing this up through the loop, and then figure out where we end up. So a little weird. And like I said, I don't really expect you guys to memorize all the math and the science behind this. I think it's just kind of interesting to know about it, and that some people hundreds of years ago went out of their way to figure this out, convert it into mathematical formulas, and then share them with us in the future so that we can figure out why a spiral looks cool on a seashell. All right. And then, of course, what we can do is we can double check that it's right. Another clever thing that you could do if you wanted is you could take this print statement and put it inside the loop. So every time the loop cycled, you could see all the values that were generated. But let's just assume this is it. So I'm going to go ahead and save this and run it. And I'm going to put in a relatively small number. I'm going to put in the number 5. So Fibonacci number 5 is 5. Is it? Wikipedia? Help. Right. 1, 2, 3, 4, 5. Except we didn't start with 0, right? 1, 2, 3, 4, 5. There it is. So if I run this again and put in 6, is it 8? Yes. If I run it again and put in 7, oops, not there. And is that correct? Yes, it is. And if you want to be really clever and run it again and put in like an extraordinarily large number, let's just throwing one up, just throwing one in there. So now you got to keep in mind here, it's going to do, at least 1,200 some calculations to do this. So you're going to watch it take a little bit longer to execute. Oh, it's already running. I have to press enter. Actually, it's pretty quick. Yeah. That's a pretty large number. Yeah. Now I have, I guess, a relatively fast machine, but holy cow, it did all those calculations that quick. So part of it is because it's operating in a loop, and if I just did like 111, even that's a huge number. Yeah. But it was faster, right?
Yeah.
See the difference. Let's do one more. Let's see if we can break the computer.
Oh, no, here we go.
Okay.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll be back. Now I did this in class too last semester, and I don't know if I used the number quite that big, but it took like 45 minutes for it to execute. Yeah. A mistake during class time, by the way. It just happened to be the last. Hey, there it is. Apparently,
Oh, wow.
yeah, that's the number. But it did it.
Can you repeat it?
Sure. There it is.
Wow.
But this ridiculously huge number, ridiculously huge, right? I'm still how many scrolls have I done? That's insane. Python did it though.
That did not take that long for that time.
No, it really didn't. Actually, in retrospect, that was pretty quick.